Here we go. So 5.1 starts. It's more trig. We're going to start with verifying trig functions. There'll be some formulas that you need so that you can do this. If there's questions on any of them, please ask. You should already know what these are, and this might help you with your problem there. So for starters, you should already know these. If you don't have these, then you need to write them down. Here are your reciprocal identities, your quotient identities, your Pythagorean identities, and your even odd identities. If you do not have any of these in your form, in your records, then you need to make sure that you write them down, because you will need them all.
Can I take a picture? I took a picture and I'm going to...
Hey, that's a great idea. I like having them available too for reference. Those are the even odd identities. Remember we said that. Not talking over you guys.
Quiet.
Which is gracious. Your question was on the last ones? They're just your odd even ones. Remember we said sine was an odd function? You plug in a negative x, you get the opposite of that. We said cosine was even. You plug in the negative, you still get positive cosine. That's all that is. Which ones are even, which ones are odd?
Wait. So the middle two are even?
The middle two? What do you mean the middle two?
Like cosine, secant, those are even ones?
Yeah, well, cosine is the reciprocal of cosine. Secant is the reciprocal of cosine.
Yeah.
So it should still be even.
Sine and tangent are odd though?
Well, sine and cosecant are odd.
Yeah.
Tangent and cotangent use sine, don't they?
Oh, okay.
So that means that it's going to make it odd as well. Does that make sense?
Yeah.
What's up? Because it's an even function.
Okay.
So if you plug in a negative, if you switch all the x's to be negative, the result will still come out positive on that. That's why it's considered an even function. Okay? Sine is considered odd. So is tangent and cotangent, because if you look at the quotient here, tangent is sine over cosine, right? So if sine is odd, then that makes the whole function odd. Think about negative or positive. Is a negative, right? So if I know that whatever sine is, it's going to just change the whole tangent thing. That's why these guys are as well odds as well. Okay? What's up? We're good? Or are there other questions, comments? Please don't pray in here. Thank you. Because I don't need you to pay attention.
Pray attention.
No, someone was praying. They were like, unless you were smelling the death.
My Lord and Savior.
All right. Not done? Sorry. You should already have these from previous lessons too. I just like them all together, huh? All right, cool. To verify an identity, we show that one side of the identity can be simplified so that it is identical to the other side, kind of like what I gave you guys for your project. Yeah, exactly. Each side of the equation is manipulated independently of the other side of the equation. Start with the side containing the more complicated expression. If you substitute one or more fundamental identities on the more complicated side, you will often be able to rewrite it in the form that's identical to the other side. There are two ways to do these, and it's not written anywhere. There is the easier way where you can change both sides, but remember, you got to keep those rules, right? Whatever you do to one side, you do the other side, unless I'm trading for something that's equal to it. So like I can take on one side 3 over 3 and replace it with 1, correct? Okay, so there is, I can manipulate both sides however I want, and then I make them match at the end. So that the left side equals the right side. That's all we're trying to do. To prove them, yeah, well, they're already balanced. All we're trying to do is make sure that the reader can look at something that says, oh yes, he went through this process and they do equal each other. So maybe at the end I get cosine equals cosine. That's true, correct? But maybe maybe it didn't start off that way. And I'll show you what the problems look like. But all I'm saying right now is there's two ways to do these problems. You can manipulate both sides. There are purists out there that say, no, to verify, you can only manipulate one side of the equation. And the other side must stay the same, and you make the right side, or the more difficult side, match the other side. Does that make sense?
Yep.
Yeah.
I'm not a purist. I don't care what you do. Just get it done. If I want to challenge, then I'll stick with just manipulating one side. But you should be able, if you need to, manipulate both sides, okay? And if you feel like you need a challenge, I say no names, then try that, you know? Pick one side, only manipulate it, and make it look like the other. Does that make sense? All right, so, go ahead.
I have a question about that.
Go ahead.
How are you supposed to manipulate one side?
Well, that's what we're going to do right now so you can see what I'm talking about.
Okay.
Okay? So, let's get started here, because that's all we're doing today. So right here I have the first identity, and they're telling me that cosine. So I'll do it this way. I'll show you how you only manipulate one side, not the other. Okay? Obviously, can you guys see that the left side is the harder side? And it almost usually is. Okay? So what I want to do is I want to show how this is actually equal to that without changing the right side. So this is only to answer Ernie's question, okay?
So wait, is this the one you're showing how to do one side and
Yeah.
so this is the one side?
This is a one-sided one,
Okay.
okay? So I'm going to answer Ernie's question here. So here's what I know. I know that cosecant is 1 over sine, correct? And I should put an X there, but I don't, guys. I really don't. It just feels like, I just feel like it's too much work for me. So I just, at the end I can throw in an X if I want. But I know that this is 1 over sine, correct? And I multiply that by tangent. And tangent is defined as sine over cosine. Oh, look at that. Sines will cancel. And I'm going to get 1 over cosine. And I know that 1 over cosine is simply secant. And now I have verified that that is true.
You just got that one.
And I only manipulated one side. That's the purest form. Okay? There's some people that will say, now personally, the one thing that I like to do when I first started this is I want to turn everything into a sine or a cosine. I hated seeing tangent. I hated seeing secant, cotangent. I didn't like any of those things. I understood sine and cosine. So one thing that I did was to convert everything into sines and cosines. Does that make sense? Can I get rid of this work here? Anybody need this? Okay, so when I started doing these, the first thing that I did was everything became sine and cosine or a 1, right? So like this would be 1 over sine, this would be multiplied by sine over cosine, and secant would become 1 over cosine. So I made everything into a sine or cosine somehow. And then I could easily see what I can do with it, right? So in this case, that's gone. I got 1 over cosine. That's equal to 1 over cosine. So I'm done.
So is that like your
This is manipulate both sides.
okay?
This is manipulation to both sides.
Wow.
Okay?
It's pretty cool. I like it.
It's pretty fun. This can be really fun. I do want to point this out, people. One thing that took me a long time to understand was that there's more than one way to do these. These are almost like little riddle puzzles. You guys ever get those? That some people just like, it takes you a little bit longer to get there, but you get there eventually. Yours doesn't, yeah, the little handheld manipulate, whatever.
Rubik's Cube?
No, that one's hard. That's okay, do that one. And I can see what has to happen, but I can't get it to work the way I want it to. Like, I know exactly how it works now. So, please do not be like, hey, let me see your work, because your work might not match their work. Does that make sense?
Yes.
Because you probably took a different step instead. And you will sometimes find multiple routes to the same thing. So here's our next one. Do you guys want to try?
Yes.
Yeah. There you go. So, whichever way you want to do it is totally up to you. Okay? And I'm going to try it too, because I haven't done one of these in a while.
Wait, I want this.
I'm going to do it on purpose.
Oh wait, no one.
Ah, that's garbage. Ah, that's garbage. Wow, Mika, say something.
We have a sign. There. Couldn't we do that?
took me longer to get the piece of paper than to do this
I
one.
don't want to do it only because like the exponents are confusing. Yeah, that's literally what it is. It's confusing, so I don't want to do it that way.
Okay. What happened to this is fun?
Well, because then you start putting exponents in this shit.
Hey guys, also remind me to give you the solution to the last one that we did, the isosceles trapezoid. We never went to got the answer on that one, okay?
Okay.
How many people tapped already?
Wait, watch it. I stopped when I looked at it. Oh, I haven't even.
All right.
I said do it.
So, I thought it was going to give me a little bit more of a challenge, but again, I've got years of experience doing stuff like this. Maybe not in a row, but I've done these and I know what to look for, okay? And hopefully that you practice these, you'll know what to look for as well. So, I'm just going to go this route. So I'm not touching the right side. Take a look at this. What do they have in common? Sine x. I'm going to factor out sine. That's going to leave me with 1 minus cosine squared. Heads up to you guys. Whenever you see any combination of either sine squared, cosine squared, or a 1 with a cosine square, or a 1 with a sine square, here's what I'm saying. A little mini lesson, okay? Whenever you see any combination of this, because I understand what's going on. If you see any of these things, you see how they're related?
Yeah.
What do they all come from?
I don't know.
Pythagorean's theorem.
Oh, like.
They are all Pythagorean's theorem relationships. Okay? And what they did, see, you guys know this one, right? Y squared plus x squared equals 1, which is 1 squared. All they did was go, on our problem, is to subtract the cosine to the other side. So let me get rid of this. Let me show you what I mean. Sine squared plus cosine squared equals 1. If I subtract cosine squared to both sides, I'm going to get sine squared is equal to 1 minus cosine squared. So what does that equal? What does 1 minus cosine squared equal? Sine squared. So I'm going to replace it here. That means that sine times sine squared is equal to all that stuff. What's sine times sine squared?
Sine cube.
Sine to the third. And I'm done.
I don't see any.
Oh, I'm sorry. You lost me when you started subtracting. You lost me at hello.
I said, oh. Let's get back to this then. Okay? So, I'm going to do it again. Sonny, you were good with what I did here? I factored out sine, right? Okay, cool. Now, I recognize this as being some form of Pythagorean's theorem. So I went over to that, wrote Pythagorean's theorem, sine squared plus cosine squared equals 1. If I subtract cosine squared to both sides, this would cancel, right? And I would get sine squared is equal to 1 minus cosine squared, correct? Yes or no? You see it?
Sure, are you sure?
You don't see it?
Well, okay, so you just like took the sine squared plus cosine squared equals 1.
Hold on, there's some side conversations, and I can't really hear you.
That's just a rule that you wrote. It's the.
That is a rule.
It's the Pythagorean.
That's Pythagorean's theorem.
You did the top part. Like you didn't change anything else.
No, that's just Pythagorean's theorem. A squared plus b squared equals c squared, right?
Okay, I need to write that.
Yes, you do. That's why we were on this slide. It's right here. Look.
Oh yeah, I have that. I just
Good.
think it was that important.
Okay. So this theorem here tells me that sine square is equal to 1 minus cosine squared. That's like saying, hey, you know what? 5 ones is the same thing as a $5 bill. Right? I can trade them anywhere I choose. So if I'm going to pay you back, do you really care if it's a $1 or one $5 bill or 5 singles? No. You shouldn't. It's the same. Your preference does not matter to me. You will take my money because I owe it to you. Anyways, I see that this is 1 minus cosine squared. I recognize that this is also 1 minus cosine squared. So I'm going to trade it for its equivalent, aka sine squared. So now I have this first sign that was there 1 minus cosine square is now going to get traded for its equivalent, sine square. And now if I have sine and multiply by sine square, that's going to produce sine cubed.
Okay.
What happened to the first one?
Yes, that's why they're equations. That's why these are gold. They're beautiful things that I can swap and manipulate any way that I want.
How do I apply it to the Wednesday project?
Well, that's a good question.
Equals 1. I know that.
There's a good question. The question was, how do I apply these rules to the problem from Wednesday, right? Now, I don't have, all these rules that I just gave you are all trig rules, aren't they?
Yeah.
Okay.
Through your career in mathematics, you were taught many rules. Like, I don't know, if I cube something that is the cube root, that makes it go away.
Yeah.
If I square a square root, that kind of cancels each other out. So you've got rules that you should have been accumulating already that you can apply the same way.
Two cube roots.
I tried that, but the 1 just keeps coming out of 1.
I know, huh?
How does it not come out of 1?
Ah, darn algebra.
Wait, can you?
Like, I see what's supposed to happen, but I can't figure out how to make it.
So let's get back to here. You guys good? Shh, go ahead. Say that one more time. How did I take what out?
You just, because you have sine x minus sine x cosine squared, so was it each one half the sine? So you would take sine out of that and make it sine times 1 minus cosine. Because sine times.
Can I show you something?
What?
Shh, shh, shh. I'm gonna show you something real quick, okay? I'm gonna do this for you. Are you ready? Don't drop out. I'm gonna use a math tool called they call it U substitution. I'm gonna take, let's go, A is equal to sine x, B is equal to cosine x. Okay? You cool with that? We're just gonna do some substituting. So every sign is gonna become A. Okay? So this is gonna be A minus AB squared, and that equals technically A squared, A cubed. You okay with that? You okay with this? Okay, cool. They both have A in common, don't they? Let's take A out. A, that's 1 minus B squared equals A cubed. You cool? Now, if I look at this, that's not where it doesn't help very much. Pythagorean theorem. A squared plus B squared equals 1, doesn't it? Right? So I'm going to take away, not A, I'm going to take away B squared to both sides. That means that A squared is equal to 1 minus B squared, correct? So you agree that these are the same, correct? So what I'm going to do is I'm going to trade this 1 minus B squared for its equivalent, that is A squared. Okay? So now I have A times A squared is equal to A to the third. What's A times A squared? A to the third, isn't it? And look at that. I just proved it again. Did that help? Good. We're good? Feel better about it?
Yeah.
That's all we're doing. The only thing is that we're used to these nice things. And yes, sine, the word sine, cosine always intimidated me as well. But understand that they're just unknowns. We don't know what they are right now. So we just call them sine x or cosine x. Okay? Can I change the slide? Shh, thank you. Thank you. Little professional courtesy here. Cell phone should not be out. Laptop should be closed. Go ahead.
How are we gonna like do this on the homework? 'Cause, like MATLAB.
No, you're not. If you can do it this way, like I just substituted all A's for sines and cosines, more power to you.
Well, no, I mean like how are we gonna write it in MATLAB when it's like
It will
x
ask.
is equal to x?
It might do. It'll push you to go through the steps. So what's the first thing you would do, kind of thing? What's the next thing you would do,
Oh,
kind
like
of
a
thing?
question help type of.
Yeah. So it'll kind of do something like that. Be like, okay, what should go here if this was the next step? What should go here if that was the next step, type thing. Okay. Now, I can already foresee some problems with that because, like I said at the beginning, The way you see it might not be the way that the person that created the math lab problem saw it. Okay, so it might end up being a guessing game at what you think they might have wanted. Okay, but there also might be some prompts as well. Okay, so it shouldn't be a big deal. All right, you try.
Yeah.
Go. Say that one more time. To verify that the left side is actually the right side. Yes, they are. No, they don't. They're not being multiplied, they're being added.
Oh, I see, I see. Don't give it like a few minutes, okay? Don't write it now. Where are you seeing that at?
Oh shit. Is this? Oh dang it! It's not multiplied.
That's what I said. I don't understand. All because it's added.
I know what to do.
These things and then you know this.
Never mind.
You can't take anything out.
Good times. Good times. Do you understand why it's only one objective today?
Yeah.
No. Why?
No. They're squared values, aren't they? That's why I said, well, look at the iterations of it. It's always a square cosine or a square sine with one.
Oh yeah, it's apple. Apple's yellow. The apple you can
Multiply by
Oh,
7
no.
to both sides.
Oh, yo.
I feel you.
Because if you did that, cosecant is 1 over sine of x, right? So if we did that, we would get rid of this sine, and over here, if we multiplied it by him, we would get
They could do that when they send the full back. But the longer you now if it's different.
Sine plus cosine. Sine x
Maybe in some rare cases it will. What? No. You're hoping. You're hoping. What? Oh yeah, I know. I don't get it either.
I know, I would put one in
They have better chances. That's it. Yeah, right there. Not necessarily. Well, you got two fractions, right? So the first thing I would have thought here is, look, there's one thing here. This is two things. How do I take two fractions and make them one thing? You gotta add them up. You gotta get a common denominator, right? You gotta do all that.
You think I'm joking? I really don't get this. The first one was okay, and now this is exquisite.
Good job. Keep going. This is not good.
I mean,
No, that already had some. So you multiply by cosine, right? Right, so if this is multiplied by sine squared. Here, or mathematically multiply by cosine squared. Or 1 plus cosine. Right? You see it?
Is that a bad thing?
would multiply by 1/2, right?
Who's still working? Who still needs?
I have to work on it.
I'm trying to like try to do it.
Are you saying no?
I'm trying so hard.
And so far.
But
But in the end, it doesn't really matter.
Why did everyone just go Lincoln Park?
I love Lincoln Park.
So do I. I'm not saying there's a problem with it.
Lincoln Park and some.
I don't even notice you. I just know. I was doing those deals.
Very much like that.
My son.
It's a tough one.
Pretty upset.
Hold on. Thank you. Thank you. On Wednesday, I want to be clear for what I am expecting. If you did not solve it, do I care? No. What am I looking for?
Effort.
I'm looking for some deep reflection. I've tried this, I've tried that, I racked my brain around this. This didn't work, let me try this. I don't care if you get to the answer.
I don't even know my name. How do you expect me?
I had to delete that information to make space for the new stuff. All right, let's look up here. I see you guys are having some issues. And that's why we do some examples, correct? Open up your mind a little bit. Here's the one thing I told the group. Thank you. If you look at the right side, there's only one term there, correct? The left side has two terms. That's one too many, isn't it?
Yeah.
So I have to combine them so that it becomes just one term on one side and one term on the other. Does that make sense logically?
Yeah.
So I've got two fractions on the left side. Sorry. Yeah, I was right. The left side. How do I get two terms to become one? Add them up, right? Which means I'm going to need a, and that common denominator is going to be 1 plus cosine multiplied by sine. No, because this is one thing, and this is the other, right? All right? Say. Now, look at the left side. 1 plus cosine was already there, correct?
Yeah.
How did I get this denominator to match what I have now?
You multiplied it by sine.
I multiplied it by sine, so I'm going to get sine times sine plus,
How do you get sine plus?
Just
Oh,
because
okay,
sine.
yeah.
Wait, go over it again.
in order for this to match this, I had to multiply by sine, correct? So if I do it to the bottom, I got to do it to the top. There's where the other sign came from.
And so then your next equation is going to be sine times 1 plus cosine?
No.
It'll be cosine.
1 plus cosine times what?
Cosine. 1 plus cosine.
1 plus cosine. Okay? So I have this right now. Make sure that you're with me. Make sure that you're with me.
Hold on, hold on, wait.
I should use another color.
Where'd you get the cosine from?
Because you
Okay, so see my new denominator is this?
Yeah.
Look at this denominator. What did it not have? It did not have 1 plus cosine, right?
Yeah.
So I got to multiply the top by the same thing.
Okay, makes sense.
Push it to the limits. So now I have all this, correct?
Yeah.
Thanks for closing your laptop, taking some notes. Are we good?
Yeah.
I'm going to clean up the top because it's kind of messy there. Here's what's going to look like. Sine times sine is sine squared. Here I'm going to have to FOIL this out. This is going to give me 1 plus 2 cosine plus cosine squared. Whoops.
Wait, no. Wait.
Oh, wait, okay, hold on. What? Hold on,
Oh,
you
okay,
lost.
okay, I got you.
I FOILed it out.
1 plus. Okay, so you did.
This in blue got FOILed out.
Oh, okay, hold on.
1 times 1 is 1. 1 times cosine is cosine. Cosine times 1 is cosine. That gives me 2 cosines, right? And then cosine gives me cosine squared. Are we good?
Yeah.
Hold on.
Okay, I got
I'm
it.
going to hold on.
Look at you.
Okay, I got it.
She got it? You
I was
good?
about to show her. Got it.
You guys cool with that?
Yeah.
Yes.
Couldn't you put together sine?
Go ahead.
Couldn't you put together sine squared with cosine squared and then make a 1?
Fantastic observation. I can take sine square and cosine square because that's Pythagorean theorem, isn't it?
yeah.
I can trade those for a
1.
1. So I got 1 plus 1 plus 2 cosine.
That's 2 plus.
1 plus 1 makes 2. So I've got 2 plus 2 cosine. Oh, look, they have a 2 in common, correct?
Yeah.
So I'm going to factor out a 2. That leaves me with 1 plus cosine. Yeah? Okay, what was my denominator? It was 1 plus cosine times sine, correct?
Okay, I see.
Right? Hold on, I missed some people because we went kind of fast there. Can I erase this then?
Yeah.
Are you good right here? Sine square plus cosine square equals
1.
the two circled ones.
Oh, yeah.
Sine square plus cosine square equals 1. So those two got traded for
A 1.
this one right here. And then all this was already there. See it? What's 1 plus 1? 2. So I've got 2 plus 2 cosine. I see that they both have 2 in common. I'm going to factor out 2. That's easy with 2 times 1 plus cosine. Well, if I took, see how there's 2 things here?
It's like 2 times 1 to make it.
Think about this. I fold it back out. I should get 2 plus 2 cosine again, right? And if I put nothing there for the 1,
That's what I did, and then I was like, okay.
okay, so we're good so far? Let's get rid of you arrows.
You pretty much just factored it out, right?
I factored it out. That's all I did. I factored out a 2 that they had in common. Okay.
And then can you divide the
At this point, I rewrote it because I haven't written the denominator for a while. So the denominator is sine times 1 plus cosine, correct?
Oh, and you could, okay. Those cancel out.
Technically they make 1, but they cancel out. This is gone. So I've got 2 over sine,
Which is the same thing as 2.
Oh, it's 2 cosine.
which is the same thing.
As 2 cosine.
Yeah, but I'm going to go ahead and use the rule for everybody. If you guys don't see this, this is equivalent to 2 times 1 over sine. How can I rewrite sine?
Cosine.
Or 1 over sine, sorry?
Cosine.
As 2 cosecant. Sorry, that's not it at all. Oh, yeah, it is. Sorry. And there it is.
Where did the X go?
I don't ever write x in there. I never write it in there. Because I feel like it messes with me.
We got
It does. It really does. So, it's bad math. Just wait till the end and write it back in. But I always take all the x's out because all I need is another variable to mess with me. So I just don't write them in. And then I come back at the end if I need to and I throw x in there. What's up?
Can you zoom it in? I'm a little blind.
A little blind. Like this?
Yeah.
Just the bottom half?
Yeah.
Right there's good? Okay.
Thank you.
Simple line.
Oh my god, how many people said that? There's like 5 people saying
Carmen, you really have to learn how to not get robbed on your bike.
Today is going by so slow. I just want to go home and eat and then go to sleep.
Actually, I'm going to stop this because that's the last example already.
Wait, so we're done? The next one.
Oh, is there another one?
Yeah, right there.
Oh, cool.
What did I say?
Yeah, ma'am.
I'm so sorry.
All right, you try.
Yeah, sister.
They're all.
Wait, theta's just basically an x, okay?
Yeah.
This one's actually kind of cool.
That's 0.
That's theta.
That's a theta, not 0.
No, like if I did it.
So in this case, would you consider theta as the x?
Yeah.
Right, theta would be like the x, and I don't even write it in. This one's kind of cool, actually.
I'm so blind. I got to take
I did it wrong already.
That's okay. That's what we get to restart. Learn from your mistake.
Learn from your mistakes.
Maybe one.
Mr. Munoz, come get some lunch and Panda.
I've been invited a couple of times already. I don't know if we can go. School nights are hard for us. Because my kids got to be in bed at 7. I mean, not 7 and 8. Well,
That's early.
at 7 we go upstairs because you have to read, and take your shower, and then be in bed by 8.
Now that is a great dad.
That's a really good system you got going there.
We got to do that. Otherwise, yeah.
So when you have like read a chapter a night or something?
20 minutes.
We did.
My little girl's really good. She was in last year in first grade. She was reading higher than 3rd grade level.
Really?
Yeah. I asked because I didn't know how they do their reading, their little dibbles or whatever it is. And I asked the teacher. I said, "Can you tell me what this means?" And she's like, "I think there's a mistake in here. Your daughter's in 1st grade." I'm like, "Yeah." Like, according to this, she reads better than my 3rd graders. And I'm like, "Well, she reads really well." Like, "Oh wow, that's pretty good." And I asked the teacher,
Do
she's
you have
like,
to do math too?
"Yeah, we do math too." I don't push them though, because I don't want to be that parent that's like, "Because I do math, you got to know math too."
But then
So-
again, you kind of.
So what if they ask me, I'll help them and I'll teach them what I can, but I don't want to force what I like on them.
Nah, I wish I had a parent that would have. Dang, that's nice.
Yeah, because I don't know. I feel like some parents think like everything should be hereditary. Like,
Especially a high school math teacher, man. I wish.
One more time.
so
I wish my parents
PTSD.
did math.
pizza. What happened?
I said
Oh,
PTSD.
does that happen? I'm sorry.
No, I'm just kidding.
Okay.
I'm just like joking.
I mean, it kind of is. I mean, they're good at math already. They kind of are. And I don't know if it's because I'm like, oh, I love math. They get excited about it too. But like, I don't push them to. I do get upset with them when they like some. You know how you guys don't pay attention? I get upset. I do the same thing. Like, "Oh, come to a teacher, you know what it is. I ain't gonna help you no more."
That's my dad.
No, but like, cause like I was like trying to explain something to her. She's like,
Yeah.
I'm like, "What's wrong? What are you doing?"
That's what happened.
But I'm like, "Why?" But you know what I think?
Whenever my dad helps me, I literally do the same thing. I'm like watching the TV, or I'm like laughing at something, or I'm like.
But see, like, I don't like understand, like, but I think it's the idea that my dad is the teacher, and that's just funny to me.
Yeah.
Is that what it is?
Yeah.
So
If
I
I
think
was in-
that's the only thing.
If I was in
Wait,
my dad's class right now, I would be laughing so hard.
yeah, just you can't see him in that role.
It's just like total opposite for me. Because like my mom, she teaches. She knows how to do math, but when I ask her for help, she's like, "Sorry, I can't." She acts like she doesn't know math. I'm like, she's just playing fake. She's just playing fake.
So-
No,
Well,
like,
what if it doesn't, doesn't come up there?
It will,
Ask her for help.
It always has to.
guys. When they ask you to verify, they already know that those two things are equal. It's your job to make it, to show that it is. They're not gonna be like, "Oh, my bad, we made a mistake."
So then they're not gonna have like questions like, "Oh, is this equal to this?"
They might ask it that way, but it's just kind of like,
But they're.
it really is. It's your job to show me.
So it's pretty much none of these answers would be no.
Okay, I type out.
They should always get something correct. All right, you guys ready?
Yeah, because got.
I need a common denominator, correct?
Yeah.
So here's what I'm going to do.
1
My common denominator will be 1 plus sine
times 1 minus sign.
times 1 minus sine.
So then you would get.
Even though that's two different things, I'm going to choose this because you guys remember the last one we did?
Yeah.
I kind of ended up with something similar, didn't I?
Yeah.
That means that I'm going to get 1 minus sine plus 1 plus sine up here, correct?
Yeah.
They both have a 1, so that becomes 2. Oh, look at that. These will cancel each other out, won't they? Gone. So I've got that. Now, in the bottom, let's... Do you guys remember these are conjugates?
Yes.
These are conjugates. Yeah. So that means all I have to do is go 1 minus sine square. Correct?
Yeah.
Oh, okay.
Now, if I have a numerator, I usually split them up in both things, right?
Yeah.
Let's see here. What can we do with this bad boy?
2 minus 2 over sine squared.
I can do that? Let me hold on. Let me think about this. Can I do that?
What?
Oh, yeah. See, wait, okay.
As long as the 2 goes to both items, I guess I could do that. Okay?
Yeah.
Yeah, so here's one fraction. Here is the other fraction.
Oh, okay. Okay.
Because remember, it's two things, right?
Oh, yeah.
But see, I feel like, yeah, it's not. We're missing something.
No, it's gonna be.
Theta.
You see that? No, hold up. 2 cosine over x squared. Cosine over x squared, wouldn't it be
Hold on.
2 over secant?
Hold on.
See, I messed
It's
up.
weird.
Would it be 2
That's
over
what I
secant
got
squared?
too. And I'm freaking out.
No. Would it be 2 secant squared?
Yeah, I don't think I can do this breakup that we were talking about here.
Why?
Because that's just one number.
Yeah.
That's just one number. So here's what I do want to do. 2 over 1 minus sine square
Equals cosine squared.
is equal to
Cosine squared.
cosine square. So I've got 2 over cosine square.
That equals 2 secant. Wait, where did the 2 over? Where did the cosine squared come from?
1 minus 1, if you do
Pythagoras theorem.
if you do sine squared plus cosine and then you take the 1 away, 1 minus sine squared equals
But we have a problem, guys. I need a sine. I can't make tangent with just a cosine. So where did I mess this up? I'm fine.
Then you factor out the
All right, well let's do this then. You guys ready? Let's keep going.
Yeah, wouldn't you just factor out the 2 from the right side then?
Yeah, on the right side, the 2 tangent.
Because you have
Well,
2
yeah,
plus
I
2
factored that
tangent
out.
squared.
And then it's gonna equal secant, and
Yeah.
secant squared, 2 secant squared, and then the other one's gonna equal 2 secant squared.
What?
She explained it really quickly.
Say that one more time.
Okay, look. Okay, so the tangent equals 2 plus 2 equals 2 plus 2 tangent squared on like.
Oh, so you're saying that we kind of have to?
You have to do it.
Okay, so here, I hate having to do this, but we're going to have to manipulate the other side here. So, because we've broken this down into its most simplest form,
Yeah.
we're going to have to do the same thing on that side because it's not. So over here, you're going to have to factor out a 2. That's going to leave you with 1 minus,
No, 1 plus 10.
1 plus
1
10.
plus
oh, 1 plus 10. 1 plus
tangent squared.
tan square.
And
That means that this is equal to, is
secant
it
squared.
secant?
Yeah.
Secant squared,
And that equals
which is 1, sorry, not 1,
2 over.
2 times 1 over cosine squared,
and then that's
which
gonna
is the same thing as what we had. Yeah, the reason is the right side over here is not in the simplest form. So we have to do that. There's no way around it this time because it was not in its simplest form. I'm just making it go higher
I'll put 2.
so it'll look better. Okay?
And when you have, there's supposed to be a 2 over the cosine.
Oh yeah, 2 times 1 is 2.
Before people get confused.
Thank you. Yeah. That does help.
Yeah, I know.
Otherwise, it looks like one long equation. You're like, what? But now I'm bothered because I didn't want to mess with the other side.
Why are you bothered now?
Because I don't want it to. I wanted to just be one side. Sorry, sometimes the purist comes out in me. You good, Queenie?
Yeah, sorry.
Okay.
Highlighting.
What else could I have done? I could have done.
I don't think you really could have done anything else.
Well, it's two things, so I could see that it's two things. I could.
Can you use my Fitbit?
I'm gonna stop this, and then I'm gonna try to do it with the.